Okay, I guess this is a selfish thing for me, that I wanted to understand more from different points of view, how to look at this from different points of view. So I will outline my view first, and then um, everyone please join in with what you think, and um, screen sharing, writing on the screen, annotating, everything is available to us to discuss this. So my view is that the traditional subjects of math are in like a narrow tower like this, but symmetry gives us an option to um, an opportunity where it's more spread out. So the reason I've made each of these blocks wider than here is because I see like multiple entry points into each of these and multiple exit points. You can go many places. So I feel this provides an opportunity to have a uh, more balanced approach rather than just this whole. If you don't know numbers, you can't do addition and subtraction. If you don't know addition and subtraction, you can't do multiplication and division, that kind of stuff. Um, what else? So while studying symmetry beautifully, there is no algorithms. You don't need much prior knowledge. It's a lot of fun, aesthetics, and there is a lot of opportunity to do hypothesis, come up with hypothesis, test it, abstract and generalize. So all that mathematical thinking will happen. So this is awesome about symmetry, and uh, I have grabbed every opportunity to do it with students. Few things I've noticed is it it has helped with geometry. So, for example, a sixth grade student came up with her own way to do this mm, perpendicular bisector of a line using symmetry argument. I was trying to recall the details, but I have lost it. But the argument was all based on symmetry, or this perpendicular to a line passing through a point outside it. Um, their own way using symmetry as an argument. And I think, yeah, if you have read any of Paul Lockhart's books, he presents beautiful symmetrical arguments in geometry. So there also definitely it helps. But is there a case to be made? I think Sanskriti has said that even commutativity is nothing but symmetry. So is there a case to be made that this is also symmetry? This is also symmetry. There's symmetry in the number line in integers. Trying to understand areas, for example. So what's the area of this uh, shaded shape can be easily understood if we look at it like this. So is this also an application of symmetry? Is this symmetry? Do we see symmetry? Can we use symmetry in clock? Clock definitely has symmetry. Can we use it? So I wanted to see, I mean, what else? What more can we do with symmetry? Um, can it give students sort of a different way of looking at all math problems, and not just um, a set of not just a narrow set of um, sort of already visual problems. So in the last TNC session, so Nagesh had posed this very nice problem, which surprisingly we were able to solve using symmetry. So the question was, um, if you have a triangle like this, okay, if you have a triangle like this, and you need to invert it by just moving the coin. By just moving the coins, you need to bring it to this inverted position. What is the minimum number of coins? And the solution turned out to be like very nicely based on symmetry. So I wanted to explore this. What are all the problems that we can think about using symmetry? Um, yeah, that's basically my pitch. So thoughts, comments.
So I just wanted to say this that generally at least for students, yeah, I mean, even for us when we were like new to maths. So the numbers and equations feels a lot more alien and not very approachable. Okay, there is some equation, there is some algorithm. There's not much clarity of what why is x into x becoming x square and what is that, those things, algebra, all these things are like more alien. I feel symmetry, or more generally I would say, like this visual way of looking at it.
Hmm.
So so I would rather translate it as, uh say there is a text, I can read it out, the same text, it becomes a voice. Maybe I can encode it and look at it, it becomes a picture. So there are so many different ways to view the same thing. So I feel symmetry, or this visual thing, poses a gives a very new dimension of looking at the problem, not in terms of numbers, not in terms of equations, but in terms of pictures. I feel this is one of the most friendly ways to approach or to introduce math to somebody who is not into it.
So you're making a case for not just symmetry, but any visual approach for. Um,
Yes, visual approach is much more accessible, is the claim.
mm,
Yeah, but symmetry in specific, I can say that congruency and all the properties of triangles and everything can be looked at it in terms of symmetry. So all like why the diagonals, all the properties like that we state, I think we can have like a symmetric lens to it. Oh, I rotate it, keep it this way, it will be the same. I fold it and it will fall on the same thing.
mm.
So yeah, I don't think we have explored this much. I feel origami, or like paper folding and properties of all these polygons. I think we can give look at the whole thing from that lens.
Anyone else?
Gauri, I joined a little late. This is Megha.
Yeah,
Um,
hi, Megha.
I also wanted to put in that is there, I mean, we could also look at different types of symmetry. I mean, or are we only looking at reflection symmetry, or what we call as mirror symmetry, right?
Right.
So there is even something that we call as rotation symmetry,
Yes.
right? And I agree with Nagesh that symmetry is one of the most friendly subjects to approach with the children, especially who are averse to mathematics. A lot of fun ways. Tessellations is also like, one another aspect that we can look when we talk about symmetry is tessellations. So tessellations and symmetry go hand in hand.
Yes. Which is also very approachable.
Yes, yes. So we used to do a lot of tessellations and ask children to bring in different tessellations when they were already introduced to symmetry.
When we talk about symmetry, I can only think of paper folding and origami, as Nagesh said rightly.
Hmm.
And the next person comes in front of me was Ashwin. That okay, Ashwin can enlighten more on this topic rather
Yes.
than
Yes. Totally.
Yeah. So uh, I think Gauri, you mentioned all the does not require so much of like background knowledge. You don't need much prior knowledge, and it's very intuitive.
Hmm.
And those are unfortunately the same reasons it's getting relegated to the like back of the textbook, and it's like treated as a very light chapter because it's
Hmm.
like because it's so obvious. People think that okay, everyone can understand symmetry so easily. So one thing that I wanted to point out is that yeah, you all have looked at. I mean, you all have brought like good points about symmetry, but in the sense that symmetry doesn't need to be just about shapes or pictures, but you can have conceptual symmetry. So in the class 3 textbook, symmetry is actually introduced through a story. So there is a there is a painter who is like asked to paint a portrait. He paints only half the portrait, and the girl says, "Oh, but you have not finished the portrait." So the painter says, "Oh, you just like keep a mirror and you will get the same thing." So the girl, she does not pay him the full amount. She only pays half the amount. She gives him like, I mean, she just pays him 100, and she says, "You keep a mirror and you will get two things, three of the face." But it's also a tit for tat thing. So it's like the painter does something bad, so like this girl also does something bad. So I want to give like an awesome example of symmetry. That is the movie RRR. So how many of you have seen RRR? Like how many of you have not seen RRR?
I have not seen. I have not seen.
Oh, okay, fine. So I'll tell you what symmetry is over here. So see, here RRR has like two big stars, like Ram Charan and NTR Jr. And they both have like big fan base. So it is like in the movie, if ever Ram Charan punches NTR, NTR has to punch Ram Charan again. Otherwise, it's like be like on fire. They will set the theater on fire. So
Oh my God.
So what happens during the story is like Ram Charan and like India, their characters are like friends, and then they become enemies. But the thing is, if you look at the story, there will be a point where Ram Charan betrays him, and it's like yeah, like basically Ram Charan puts him in jail, like puts Junior India in jail. But now it's like later Ram Charan like rescues him from jail also, kind of. And later in the story, NTR also rescues Ram Charan from jail. So when you are having like,
Are you saying that they just had to make half of the story and the rest half of the story was
no,
Inevitable. The rest half is inevitable.
was
you could say
inevitable?
that, but it's like, I mean, you could see it as an additional constraint, or you could say that, okay, if you write half the story, the other half writes itself.
Yeah, right.
So the antagonist and protagonist, they are like almost evenly matched, and it's like they are cousins and things like that. So you basically, my point is, you can have symmetry at a very conceptual level also. This
Interesting.
person does it, that person also does it, or it's like there is good and evil fighting, or like there's black and white fighting, and you can even like take it to a very philosophical level, like yin and yang and all. But the thing is, I mean, children don't care about philosophy or like good and evil and things like that, but they can intuitively say that this thing is like, look, this thing looks balanced, this thing looks neat or something like that. So similar, but even at a conceptual level, and I feel that even young children can understand the story, like at a conceptual level also. So because of all these things, yeah, basically symmetry is like approachable on so many other directions also. Yeah, so unfortunately, the thing is because it's intuitive and because you can't like logically deconstruct it, like attention. It's like symmetry. Maybe some painter might need symmetry, but why would anyone else need symmetry? But I think it's like it's a very beautiful subject, and like all of you mentioned,
One more
subject
thing about symmetry.
is new to math. Yeah, so that was just my thought.
Yeah,
I want to add one more thing. Sorry.
Yeah.
Okay. So while Ashwin was saying, this came to my mind. Basically, symmetrical objects, physical objects are also more aesthetically appealing. Though now there is a different school of thought in design that, you should try to make designs which are not necessarily symmetrical. But originally, the concept of any product that was designed to be symmetrical was more catching to the eye, was more aesthetically appealing, was more beautiful. You can look at bridges, or you can look at purses, or you can look at any object. A lot of objects that we see or use in our day-to-day life, spoons, forks, all of them, pillows, beds, or phones, or whatever, pants, shirts, etc., etc. A lot of them have symmetry about them, our bodies. um, so yeah, that was a natural, one is that nature also has a lot of symmetry, and one is like design incorporates a lot of symmetry because it is more aesthetically appealing.
Symmetry is also used in finding some winning strategies for games. And as when I was just listening, I just remember that suddenly that we use this in many games.
Can you give an example?
Yeah, sure. There is this simple game, 6, 7 petals. Let us call this game as Color the Petals. This is a 2-player game. Let us say Gauri versus Megha. So you are allowed to color 1 or 2 petals. And the condition is that if you want to color 2 petals, they must be connected. You can't color 2 and 4 or 3 and 6. But 2 and 3 is allowed. 1, 2 is okay. 1 and 7 also okay. So they must be connected. That is the condition. The person who colors the last petal is the winner.
Okay.
Like to start, Gauri?
Yeah, I'll start.
Megha?
Just clarifying. So I have to color a petal connected to her petal, is it?
No, not necessary. You can color 5, 6 or 6, only 7, whatever you want.
I can connect to
Want to
color one petal or 2 petals.
They must be connected.
So 2 petals I can connect.
Yes.
Color.
Yes. 2 or 1. It's your choice.
Oh, 1 or 2. Okay. Right. 5 and 4.
Gauri. Basically, she used something.
Okay, I will do 7.
So whoever does the last wins, right?
Yes. The person who colors the last petal is the winner.
2.
2. So now
I'll do 3.
Megha is going to win. If Gauri
Yes.
colors 5, I mean 6, she will color 3 or the other way.
Correct.
So can you explain, Megha, what you use?
No, since we are talking about symmetry, I tried to be as symmetrical as I could.
Okay, you want to play one more time? 8 petals this time.
Oh, okay. The petals can change, is it?
Yeah, it's up to us. Nagesh versus Ashwin. Come on.
Yeah, okay. Who will go first?
Yeah, that's the most important question, Ashwin.
So,
Okay.
Nagesh, I think the second player will win. So,
Oh, okay. So I'll go first.
okay.
4.
4.
So I will choose 8.
Which one?
8.
8.
I see. Yeah.
What
No matter
happened?
what I choose,
Can you
he
explain
will
what
choose.
happened?
Okay, yeah, 6.
6.
I will choose 2.
Can someone explain others what's happening here? Yes, Nagesh, go ahead.
Yeah.
No point playing anymore.
Yeah. 5.
Whatever he plays.
I will choose 1.
So again, Ashwin is going to win.
Hey,
Huh.
this is a wonderful game.
Very nice game. Lovely.
Yeah, I have 2 questions. Number 1 is that right now I think if the number of petals is odd, the first player will win. If the number of petals is even, the second player will win. My other question is, do we need the condition that the 2 petals, if you are coloring 2 petals, they need to be connected? I mean, is that condition necessary?
So even when it was odd, I mean, I played first, but I lost.
I think you might not have played optimally at that time. I mean,
Okay, we'll do it again.
okay, yeah, I will play
2, 3,
first player with odd number of petals.
5, 6, and 7.
I mean, I'm not sure. I'm just like guessing, but we will see.
So what we are trying to find out?
We are trying to find if the number of petals is odd, the first player will always win.
First player can win. And if it is even, in that case, second player can win. That is what we are.
That's the hypothesis. Yeah.
Okay. So, Ashwin, then you start.
Okay. So
I feel Ashwin will lose no matter like if the second person plays properly.
Okay, so
Okay,
Nagesh, you can go second. Okay, Ashwin, start.
okay, yeah, I'm just thinking. 1, 2.
5.
So yeah, I choose 4. Okay. 7.
After the 2 moves, the scenario was the same, but it got flipped.
Mm.
So yeah, it was interesting that after the first person colored, there was a choice for the second person to make it symmetric, no matter what the first person does.
Yes. And that is where the winning strategy lies. Suppose he colors for one petal, then we will color this. So whatever he plays, we have counter move.
Right.
And that is where the symmetry plays a role. And there are many such games where symmetry is used as winning strategy. And in this case, second player usually wins again.
Oh, so it's like irrespective of the number of petals, the second player is winning.
Yeah, irrespective of number of petals, because we are coloring 1 or 2.
Hmm.
If we change, now we can change it to, let us say, 3 petals. I mean 1, 2 or 3. Then we have to see how winning strategy changes.
So one of the questions we had at the end of the first 2 games was, is that rule that only 2 adjacent, I mean, when coloring 2, they have to be adjacent. Is that rule necessary was one of the questions. That has also become apparent.
That is not clear to me. So Gauri, can you explain why?
Yeah, so if you can color any 2, then it's just, it's like NIM. It's no different than NIM, and that strategy will apply.
Yes.
Yeah, it reminded me a lot of NIM.
You can even convert these to NIM.
But NIM, the first person wins if they both have same.
Yeah, in regular NIM, but obviously there are many variations. So
yeah.
You can,
but here also in NIM, it depends on the number you start with, right? So the number of pebbles, if it's like a particular number, then the second player will always win.
Okay.
Here also we can say, if you are taking means crossing 2 balls, they must be connected. I mean adjacent to each other. That can be a condition in this NIM. Then it is similar to this, but it's obviously it's not exactly same as this, because here these 2 are separate, 1 and 8. If we take 1, 2 and 3 here, still that is the rule.
So this is dependent on like breaking the pool into 2 equal parts, right?
Yes. Whatever your opponent plays, you have one move exactly same on the other side.
Right.
Yeah, it's going to be a very nice point introducing symmetry in games.
Yeah. There are also these bunch of games where the best strategy is mirroring the first move. The second player just mirrors the move of the first player, and that's the best strategy.
Yes.
There are also such games, so that is also interesting.
So I want to bring up another question here. So these things, I think we are in a place where we are appreciating these things, but at least in school, yeah, this is thought of as like a fun play thing, which is and not like mathematics. So if we purely look at it in that lens, so I'm sure like many of you would have come up with like use symmetry in other places other than geometry. So if anybody can share their journey of how they have used, and to basically highlight the importance of symmetry and how it could be used in other chapters of mathematics.
So one example that I can see is in equations. So if you are solving for equations, you can view linear equations as a kind of left hand side and right hand side as being a balance, and whatever you do to one side, you should do to the other side. So it is a kind of symmetrical action that you do to the left and right side.
Linear symmetry.
At a kind of high school level, I can think of symmetry in like certain formulas. Say, for example, you have distance formula in coordinate geometry. You know that has to be symmetric with respect to x and y. So if you have 2 points, the distance between the 2 points is going to be root of x1 minus x2 square plus y1 minus y2 square. So intuitively, if like I told you that the distance between the 2 points is x1 minus x2 square plus y1 y2, that would seem like weird. So you can see that the variables, that is the axis x and y, it should appear symmetric in some way. Now you, I mean that is, again, this is not a logical argument, but it's a very intuitive argument. But you can see why that formula needs to be symmetric. So in that way, you can see that a lot of formulas are going to be symmetric with respect to variables and so on.
Interesting. So since the axis is the way it is, so if I flip it, then the distance, yeah. So if I change x and y coordinate, essentially I'm changing, now my x-axis is y-axis and y-axis is x-axis. But just changing the axes doesn't change its respective distance to from the origin, say. So the distance formula needs to be symmetric with respect to axis.
So you can take the formula of area of a rectangle or total surface area of a cuboid. So for example, say if the area of a rectangle is 2L plus B.
You mean perimeter?
No. So assume that the rectangle is 2L plus B.
Okay.
Instead of 2 into L plus B.
Okay.
So now you can see that this formula feels a little off because it is like favoring length over breadth in some way. So, but you intuitively know that if you like rotate a rectangle over 90 degrees, perimeter remains the same.
Right.
So if you have this formula, then by rotating the rectangle by 90 degrees, it will give a different perimeter. So you know that the perimeter has to be like a formula which is symmetric with respect to length and breadth.
Right.
So similarly, now area also is going to be therefore like length into breadth, and it cannot be like, I mean, so it is basically symmetric with respect to the variables.
Yeah. So with respect to the distance formula, what you were saying was it is like x2 minus x1 whole square minus y2 minus y1 the whole square root of this. So essentially what we are doing with x, we are doing with y as well.
Yes.
That's what you were referring.
If I change x to y, it will not affect the formula. So yeah, one other interesting thing I wanted to mention was the thing of why why area of any triangle is half into base into height is essentially a symmetry argument.
But this can also be done, shown visually or geometrically, right?
Yes. But that showing it visually involves aspect of symmetry.
Yes, exactly.
Yeah.
There is one more game, like this variant of NIM on a grid, where you have to place a stick with adjoining boxes, either vertically or horizontally. No,
Like,
you have to place a stick in two boxes, two adjoining boxes, vertically or horizontally.
Like dominoes on a chessboard.
So,
I mean,
Like-
the placement I'm saying.
yes, correct. Like domino placement, correct. So whoever is the last person to place the domino wins.
Right.
In what I have to add is again like
The way you play it.
very algebraic,
Dominoes is exactly two pieces.
which is like so we are talking about. So we were talking about this symmetry of formula like 2L plus B.
Mm.
I think we also define a whole class of polynomials called symmetric polynomials.
Symmetric polynomial.
Which,
Okay.
yes. So I'll give some examples of symmetric polynomials. So in 3 variables, let's say x, y, z is a symmetric polynomial. Xy plus yz plus zx is a symmetric polynomial.
X
X square plus y square plus
what?
z square.
Hold on. XY plus
YZ,
YZ
Meaning
plus
equal.
ZX.
YZ. Yes.
Okay.
ZX.
ZX.
Yes. Okay.
Or say x square plus y square plus z square. So essentially, like in every term, sort of the I don't remember how we define it, like, but I remember some examples of or XYZ. And so we define this whole class of symmetric polynomials, and it so happens that if we want to find roots of some polynomial in one variable, and we are able to find the symmetric polynomial which has coefficients of it, it means that we can sort of compute the roots of it quite easily. So again, I don't remember the exact procedure of how to do it or algorithm, but yeah, it helps in finding the roots of polynomials in one variable somehow.
Achha.
Look at the algebraic identities of middle school, they will all be symmetric expressions only.
Yes, right. Yeah.
Like A plus B whole squared.
Huh. So that would be like the simplest case. So that will be like, yeah,
What do you mean by this is symmetric?
that is, you can interchange A and B and the expression will be the same.
Okay.
So if there's an A square, there'll be a B square. If there's an A cube, there'll be a B cube, like that.
Oh, okay.
Yeah, I think this symmetric polynomial is a generalization of something like that only. Like
Correct. Yes.
Yep.
Oh, this is completely new for me.
Okay, so this will be A plus B plus C into something. Yes, so I am saying the factors will also be symmetric.
So I almost feel like what is that? So in physics, if you look at the units, like you can easily validate whether things are going right or wrong, right? I mean, for example, you velocity is distance by time, so it has to be like kilometers per hour or meters per second or kilometers per second. That, what is that called? There's some name for it, no?
Dimension analysis.
Oh, okay, whatever. So I almost feel like understanding symmetry can give us that kind of point of view even in algebra.
I think related to this will be Pascal's triangle. So that is also symmetric. And yeah, it's like so Pascal's triangle, it will be symmetric, and you can logically see why it has to be symmetric also.
I wanted to ask a question. That particular grid game that somebody mentioned, is that of Japanese origin? I think I've seen it somewhere.
It's a variation of NIM. I don't know the origin.
Oh, is it? Okay.
Shravan, do you know the origin?
Basically, we are putting the dominoes, placing the dominoes so that the last person wins. Is it something like that? What?
Yeah. So
The last person who places wins. Yeah, correct.
if
Okay.
you cannot
Okay.
place, then you lose.
It is something like one can place horizontal and one can place vertical only.
Yes.
Yeah,
It's
either
like
horizontally or
dominoes.
vertical.
Yeah.
No.
Okay.
No, it's like
No.
the player can
It's like
place
one
either
person
in the
only horizontal and one person only vertical.
No.
No.
Each
No.
person can decide each turn how they want to place.
Okay, but there is one game like that also. Okay. One is V and one
Oh.
is H. So one V will place only vertically, horizontal will place only horizontal. And
Oh,
again,
wow. Interesting.
rest
Very.
is same. Yeah.
Here again, the grid will matter, no? What kind of grid and
Yeah, of course. Yes. Grid
so
will
empty
matter.
spaces.
Yes,
Empty spaces are allowed.
Yes.
allowed. Yes. Yeah.
Oh, okay.
You have to block your opponent so that he or she cannot place his last domino.
Okay, got it.
So Shravan, you were saying symmetry comes into play here.
So I've only heard that symmetry is a strategy for gameplay, but I have not analyzed or understood.
Oh.
See why it is so.
Yeah, I think we've covered quite a lot of ground. So where do we go from here?
One question to ask is it taken like I think somebody already mentioned about it today. Is it taken seriously? I mean, is it given good importance when, or is it taken as a very frivolous topic
Yeah,
because of its ease, or I mean, at least supposedly.
it is considered trivial and it's the first on the chopping block whenever time is insufficient. And even if they do it, a very superficial treatment is given. Okay, draw the line, draw the reflection. So, yeah.
So
Trivially, in
can
what sense?
we talk about how not to untrivialize it, or I mean, in schools, what do teachers need to
Megha, ma'am,
know?
trivial in
Sorry,
what
sorry.
sense? Can you elaborate on this?
Yeah, basically, I have also noticed it's like sometimes it is given like you do it yourself. That kind of, if you do not have time, if the teacher doesn't have time to finish all the chapters, then this particular thing is like given very less time, one period.
Okay.
Or you can you can do it yourself. I'll share some videos, something like that.
Oh, okay.
So maybe one discussion that could go is how to untrivialize this topic. Basically, what to tell the teachers that it is not so trivial as we think, or for the students. I think teachers should be.
So, the reasoning behind trivializing, like Ashwin was saying, is students can do a lot of the problems given in the textbook by just using intuition. Teacher doesn't say she has to teach it. Okay, students can do it intuitively. And there is no way for the teacher to teach it. Like, that also Ashwin said very nicely, that it cannot be deconstructed. So
Another thing that comes to my mind, Gauri, is some kind of students, okay, pick it up very quickly as compared to some other kind of students, like
yes,
who have a certain bent of mind. You could say that.
yes.
Symmetry, or I mean, I'm especially talking about visual symmetry here.
Yeah. Some
students
will have,
like the simplest of the, or simplest name. I mean, I don't think we should use that word simplest, because every child is thinking differently. But what is very simple to some students may become very daunting to others when thinking about or visualizing it in their mind, or why.
Yeah.
That's symmetry.
So what do we mean by untrivializing it? We don't mean make it difficult that students cannot use their intuition and solve it. That's not what we mean. By saying untrivialize, we mean that teachers recognize the beauty and importance and give it sufficient time. That's what we mean, right?
Yeah, exactly. But how to make that happen? Somehow I have noticed that the children seem to enjoy this a lot. So another thing that is done is, like, between two kind of heavy topics, this topic is put in so that you can lighten up the content, or light. That is also done by many teachers I know.
That I don't mind. Yes, it is fun. So
That is
let's
good.
have fun.
The children
That's fine.
think that it is the light. Arey, chalo, we are going to have something. Abhi bahut number theory bahut ho gaya. Abhi let's do something different, something like that, no?
Mm. Mm.
So at least my feeling is, say, to take something which is like well known, say area of a triangle or any of this, and try to nudge it to, okay, why this is true, and trying to bring out symmetric arguments to prove something, or trying to show these things might be somebody who has not seen it. If they see these things, that could lead to, oh fine, I never knew symmetry was used to do all this. If we are able to bring out this feeling within a teacher, I feel they might give more importance.
So bring up symmetric arguments in every other topic that we, as far as possible.
Yes.
Basically connecting it with the other topics of mathematics, right?
So one thing that I noticed is that the topics which most students find difficult, and therefore the teachers are also concerned, is those are the topics which are usually involving a lot of symbolic manipulation. So that could be, say, fractions or algebra and so on. Or they could be topics where there is a lot of like algorithm and like rote learning thing. So like construction, for example, it's now boiled down to a set of instructions you have to follow.
Yeah.
So it is like it has become that if there is a lot of writing, then that is difficult, that is important. If there is not much of procedure to follow, if something is very intuitive, those are the subjects people treat very lightly. So, for example, if you take 3D solids, uh, like in, like, say, class 9 or class 10, you will have volume of solids and things like that. But until then, it is just that they are just given as examples. Yeah, football is a sphere, ice cream cone is a cone, and yeah, that's all.
Yeah.
Because it is so visual, and there's very little writing or procedure involved, people think that they are like topics. So it is like we have a bias there. If something involves a lot of writing, that is an important topic. That's what we should spend time on.
True. Agree.
So what I feel is, like, when we teach also, this writing part and procedure part, it should come much later. It should come like at the very end, when it's like your intuition is no longer helping you. So intuitively you see something, but that is not taking you all the way. Now that is why you need this writing and so on. So instead of, say, linear equations, you just have this simple things like two ice cream and one milkshake is 100 rupees. One milkshake and three ice cream is this much. Now can you tell what is one milkshake, what is this, something like that? Because there it's like intuitively you understand what you are trying to get, but you still don't have the tools to solve it. So now at this point you introduce variables and things like that, and then it makes sense. But because like the curriculum is like too symbol manipulation driven, we jump into that so quickly. So that is why every student finds fractions very difficult, because we are teaching them how to write, that is that multiplication, division and all, before they are ready for understanding what it means. So yeah, I would say, can you think of other topics which are treated lightly because they don't have enough writing to it.
Graph, bar graph,
Ah,
statistics, all those things are
hmm.
given least importance.
Yeah, this is a good example. So
Mm.
again, it's like because it's visual, it is given less importance.
So here is the thing. As long as the teacher feels that the procedures is what needs to be imparted, when there is no procedure, then there is what is her need to do anything? Because the whole of teaching is just this. So if there is no procedure and intuitive, basically there's no work for her. In that sense, in that light, I think this is being ignored. So I wanted to, okay, I don't know whether Shravan is there. If we can include problems and games, games such as this. I think NIM game is also there, but yeah, including it as a part of textbook is one thing.
Do you mean like you want to include it within the topics itself and not just keep it as a separate chapter?
Yes. So it somewhere has to be like it has to
Part of some chapter.
part
We
yeah
see the
part of
application of that
yes.
thing.
So even the one other thing I was thinking of is this formal way of writing proof should come way later.
Yes.
I feel this is proofs should be looked at like, okay, I do this. How can I, or can I logically argue and come up with statements, sound statements, to say something, and can I, like I move this piece there, and this is same as this. So these kind of things. Has to come out. For that, I feel symmetry arguments are like very strong arguments for proof. But since the whole structure is so formal, there is less scope. I feel if we can somehow relook at how these proofs are done uh, and bring in some of these symmetric arguments to say something, that would be nice.
Srilata has posted a point that more than it is visual and easy, teachers will give importance to those topics which have more weightage of questions in the question paper, as that's how both children and teachers are assessed.
Yes,
And in the
that is
process
true.
of portion completion, easy ones can be completed faster, and that's how it gets neglected. Yeah, that's very true.
Yeah, I think maybe including few hard symmetry problems would also bring out like, oh yeah, this is not as easy as I thought.
We can
Okay.
even include something like this. I mean, our textbooks. We have to give half the diagram, and then you have to complete it like a mirror line symmetry. And sometimes it's not at all easy. Give it on a grid paper, and then you have to count. Means for younger kids, it's not really easy. We may
Yeah,
think it
even
is
for me, it's
simple.
not easy.
Yeah, yeah.
With a diagonal
Yeah,
line of
even sometimes,
symmetry
yes.
and
Even for me, if it is a
yeah,
big figure, then yes, you have to take efforts, count that, and the
yeah,
basic concept is not clear for kids. That if it is two dots away on left side, then same you have to count on the right side and all. So those type
right.
of activities are really interesting, and probably kids will enjoy, and they will
Yeah.
understand what the symmetry is in true sense.
Yeah, I think we'll wrap up unless anyone has a few last comments.
I think the point that Shubhangee brought up was like really nice. That is, there are a lot of games which use symmetry.
Yeah,
I think we can like build up a lot of games, maybe in the next session where like symmetry strategy works. So we can find more examples of games like where you can use symmetry.
yeah,
That flower thing is a very good example of radial symmetry at work, and then of course the mirror symmetry as well when we are playing it.
So another thing, like game theory is like one of the subjects. but I was also feeling, why do we teach children things that are like, I mean, that they cannot appreciate, at least at that level. So these kind of games and coming up with a strategy to win is such a nice thing for a kid, right? And there are all like, so every aspect of math there are applications. So somehow, if we can relook at this, like what children enjoys at that age group, and then what kind of topics in math should be introduced to them, which are first enjoyable to them, and they are able to look around and then relate to. And of course, with every math topic, all the math skills that needs to come out. But yeah, if we can consider that, I think that will be nice. And I feel like, if we can remove some of the topics from our books and introduce way later, and give more emphasis to say game theory, could be like, just like how we have like algebra, geometry, game theory could be like, one of the main things,
Hmm.
right? So why only teach these things?
Shravan is not here, unfortunately.
Oh,
No,
okay.
but I have found like a great idea from what Nami said. That is, if you just teach it as games, everyone will think it's like very trivial. You just add a word theory to it, and now it becomes like really important. So if you include game theory, people will definitely study it properly.
Mm.
Right. Marketing also is.
Okay, thank you, everyone. It was really nice discussing.